Right, let's have a look at working out limits by looking at the graph of a function this time. So we've already looked at this function f of x is equal to x squared over x in a previous video, and we had sketched it, and this graph of the function looks like this. You can see there's a break when x is equal to 0. We explained that before, because if I fill in x is equal to 0 in this function, I'll end up dividing by 0, and we can't divide by 0, so that's why there's a break. So this is not a continuous function, but we still want to work out the limit as x approaches 0 of the function f of x. So this is the function f of x here. We want to work out this limit. So what the question is asking is, as the value of x gets closer and closer to 0, now it never gets to 0, because we know that it can't actually reach 0, because when it reaches 0, then we'll end up dividing by 0, and we can't do that. But as it gets closer and closer to 0, what happens to f of x? What does the value of f of x get closer to? So let's have a look at the graph. So when x is equal to, let's just have a simple example first of all. When the value of x, this is the x-axis, so when the value of x is equal to 2, what is the function f of x is equal to? Well, we can look at it from the graph. So when x is 2, f of x, we can see, if we draw a line up here, and then across, we can see when x is equal to 2, the value of f of x is also 2. When x is equal to 3, we can figure out what f of x is. When x is equal to 3, f of x will equal 3. When x equals minus 1, f of x equals minus 1. So we can just figure that out by drawing a line from the x value down to the graph and then across to the f of x axis. So as the value of x gets closer and closer to 0, and remember it can get closer to 0 in both directions. We can get closer to 0 by coming across here. So the values of x are getting close. As I move my pen across, the values of x, I'm on 3 at the moment. So as I move my pen across the x-axis, the values of x are getting closer and closer to 0. And if I come from this side, as I move my pen across from left to right, the values of x, minus 3, minus 2, minus 1, minus 0.5, are getting closer and closer to 0. So what's happened to the function? As we go from both directions, what does the function get closer and closer to? So when x is 2, f of x is 2. When x is 1, f of x is 1. When x is 0.5, you'll see f of x is 0.5. And come from this direction. When x is minus 2, f of x is also minus 2. When x is minus 1, f of x is minus 1. When x is 0.5, f of x will be minus 0.5. So what's this number in the middle? Look at these values of f of x. We got 1 here, say this one, and then we got this one up here. If I keep squashing these two lines together, I'm just going to shade them in a bit more. If I keep squashing those two lines together, going this direction, what will they squash onto? What will they get closer and closer to? And you can see they actually get closer and closer to 0. So even though we can't fill in 0 into this function, we can never fill in 0 because we'll end up dividing by 0, we can still see from the graph that the limit, we can still work out the limit as x approaches 0. So the limit as x approaches 0 of this function f of x is actually equal to 0. Because when I squash those two lines together, this one and this one, I will get closer and closer to 0. Okay, so let's have a look at another example of that. So we have this graph here. Let's call the graph g of x. So this is the line. It's a line, g of x. It's a function. So we want to work out the limit as the value of x approaches 4 of g of x. So I don't know what the function g of x is. It doesn't really matter. We have a graph of it here. It looks like this. So as the value of x approaches 4, so as x approaches 4, I'm going to use a different marker, a little bit thicker. Let's say as x approaches 4, so here's the x-axis, here are the x values. As they approach 4, they come across this way. So we're coming this way. And we can come approach 4 from this side as well, so we come across here. So we're approaching 4. So what happens to these values of f of x as the value of x approaches 4? So let's have a look at a few of them. So we could go, okay, when x is equal to 2, we can see that f of x, the value of f of x is, what's that, around about, there's 1, there's 0, so it's just above 0.5. When x is equal to 3, we can see f of x is something like, it's around about 1.5. When x is equal to, let's say 3.9, let's come in here very close to 4, but not quite at 4. So when x is equal to 3.9, what is g of x equal to? And if we draw a line across, we'll get around about 2.3, something like that. So we're getting very close to 4 there. Let's go from the other side. So say when x is equal to 5, what's f of x, or g of x, sorry. when x is equal to 5, g of x is around about 3.5, 3.4, 3.5. We could get much closer. So let's say when x is equal to 4.1, we're getting closer to 4, so let's go to 4.1. So here's 4 is this line here, that line there. We go 4.1, which is maybe there, which is very close to 4. You can see it's in the middle of those two lines. So when x is equal to 4.1, g of x will be around about, let's say, what's that, maybe 2.6, something like that. So what happens as we get closer and closer to 4? So when we squash those lines together, getting closer and closer to 4, what happens to, what's the middle line? What happens to these two lines? So if you look, this is 3.9 and it's coming out to here on the g of x axis. This is 4.1 and it's coming to here on the g of x axis. So when we squash those two lines together, these two lines are getting squashed together. So what does g of x become? So I suppose it'll become whatever that is there. That's like the middle part of those two lines. And that's around about, well, we've got 2 there, we've got 3 there. So I suppose that's around about 2.5, something like that. So it's very hard to get an exact value from a graph, but we can see that it's around about 2.5. So we say that the limit as x approaches 4 of g of x is equal to, we'll say 2.5.